So we had not done this one together, but I wanted to show you a more complex one just so we understand the steps. I'm not going to solve it all the way down. I'll leave that to you, but I am going to show you how to break this problem down just a little bit. So first step, we look to see if we can simplify the denominator. And I mean, I hope you understand what I'm saying, but I just want to confirm because you seem like you do get it. But we have this up here, and we have this down here, this up here, this down here, this up here, this down here. For this first one, is there anything I can simplify in my denominator that I could like divide from the top and the bottom and get rid of? I'm thinking the same thing for all of these. There is nothing, right? There's nothing I can simplify in the bottom. There's nothing I can pull out. If I could pull out this five, I would, but I can't because I can't pull out I can't pull a five out of both of the terms, so I can't pull that out. Um, so yeah, there's nothing to pull out here. So we're going to move to our next step. We're going to determine our restrictions. Number two. So we can set our denominators to 0. We know for a fact that this one tells us that n cannot be 0, but let's look at the other ones. N cubed is 5n squared, set to 0, and n plus 5 set to 0. So I'm just solving down for n, or solving down for what it would be. So I can pull out an n squared here, which leaves me with an n plus 5 equals 0. Then that's just n squared set to 0 and n plus 5 set to 0. And then this is already n plus 5 set to 0. So these are going to end up being the same. So that just means that we already did this one. So n can't be 0, which is what we already said, and n can't be -5, because that will make our denominator 0, which we cannot have. So yeah, think we're good to go on that front. So let me erase all of these, but we have our restrictions over here. Then our next step says determine our least common denominator, our LCD. So let's do that. We need to combine our denominators. This is where that combination really comes into play. You have to think about what that means. We're going to combine them all through multiplication. I'm gonna kind of do it just like this to make it nice and clear. But I am not going to combine them into one simplified sentence. I don't need to do that because these are going to help us see what can cancel out so we can get rid of our denominators. So this is our LCD, but we're going to leave it just like that. We're not going to do much else with that. That is our LCD. Then we're going to multiply every single term by the LCD. And that equal sign means it's not an expression. So I have to combine I have to multiply everything. What I do to one side, I have to do to the other side. No exceptions. So that turns into 5 over n cubed plus 5n squared. This is one single term, times my LCD, which is n cubed plus 5n squared times n plus 5 times n squared all over 1 equals, and I'm going to get to the other terms because this is really big, so I'm going to start simplifying this first. This simplifies here, where I can go ahead and cancel out this term with that term in my least common denominator. We see that, right? So that just canceled out and got rid of that one, which was a one part of our least common denominator. And it got rid of the denominator on one of our terms, the term that we got it from. So each piece of our least common denominator has a mission. It is to take out the denominator of the one that it came from in order to put everything on one line, no fractions. So that's 5, n plus 5, n squared, because I had to multiply it by what was left. Now equals my next two terms. So 4 over n plus 5 times my n cubed plus 5n squared um, times n plus 5 times n squared all over 1. So ugly. I'm going to do it term by term because it's just too much. So I don't want to lose this that I did on the other side. But now I need to go ahead and cancel out what needs to be canceled. This did its mission. It got rid of that denominator. And now we have 4 times n cubed plus 5n squared times n squared all over 1. And then I'm not going to put it over 1 though. We don't need to do that. But you get what I'm saying. That's just too much more space it's taking up. And then finally, our final piece, because there's that plus sign that I'm not willing to drop because I don't want to drop that. So I kept it even through here. And then our last piece, which is going to be 1 over n squared times that really messy, no, no space, that really messy LCD that hates us. Okay. And then we see what we can cancel out. You can't really see it because it's so messy, but this n squared that we pulled in our least common denominator cancels that out, and then we're left with what we're left with. And then we finally have something that we're going to combine. Give me 1 second to write out this monstrosity. N squared. Ooh, we can now solve this. And we're going to try to solve it for n, but you may have to combine it and see what you get. If you get a quadratic, so your leading term is n squared or more, if it's n squared plus, so n squared, n cubed, and you're leading your first term, your largest degree, is squared or bigger, then everything needs to be brought to one side and set equal to 0. And you solve with cubic factoring or you solve with quadratic factoring, whether that's using your quadratic formula or any other factoring methods that you know to get the value of n to solve for n. But that's how we would get down to this piece here. I'm not going to solve it any further. I'll leave that up to you. But getting to this part is the important part. And use those steps, okay?